Hey, good morning, everyone. My name is Shruti Anim. I recently completed a cloud resume challenge, and I thought I'll do a demo of it so that for someone who is in the similar path as mine and would like to pursue this challenge, it'll be helpful. So, to get started, we will be doing a demo in these series of steps. First, let us talk about what a cloud resume challenge is. So, the Cloud Resume Challenge is basically created by Forrest Brazil, and he created the resume challenge in different versions. It's in AWS, it's in Azure, and GCP. At the end of the challenge, you basically create a portfolio website for yourself. If you're not interested in creating a portfolio website, you can create something new, but the whole essence of the challenge stays the same. It's divided into 16 steps. First, starting with certification, and then you will be creating static assets such as HTML, CSS, and host a static website, followed by securing your website, creating a custom domain, and associating with your static website. And then you will be writing some JavaScript code to actually update the front end with a visitor count. The creator wants you to update the number of visitors every time your site is called. And for that, you will be also having a database to store the visitor count. And then you'll be writing an API so that the backend and front end can communicate. And then you have a Python code which you will be writing to create your Lambda function or Azure functions for the communication between backend and frontend. You will have some test automation scripts that you will write for your smoke tests. And finally, the last couple of steps are related to the CI/CD, where you will be creating infrastructure as a code. So instead of creating all this infrastructure through the console, you will be creating it as a code which will be deployed. And then finally, you have to write a blog post explaining your experience and share it on any social media platform. So that's about the Cloud Resume Challenge. And all these 16 steps have been divided into four different chunks. Chunk one, which is about building the front end. Chunk two is building the API. Chunk three is front end and back end integration. And finally, chunk four is automation and CI. So first, before we get started, I want to show how the final outcome is going to look like. So that we can then try to destroy the infrastructure, rebuild it, and see how that impacts. So first, let's visit the website that I have created. So this is the website that I have created, and this is the outcome of the challenge. And I have a visitor count, number of visitors 59. And then I have different sections based on whatever you want to incorporate. You don't have to have all these sections. You can have a single page for your portfolio. The whole essence is you have to increment the number of visitors every time there is a new visitor accessing your website. So when I refresh, it would automatically increment it to 1. So that's how the end project will look like. So as part of the third step, let's take a look at the architectural diagrams so that you understand the end-to-end workflow. So there are two different workflows, one from a developer standpoint and one from a user standpoint. So first, let's take a look from the developer standpoint. So what happens when a developer pushes the code? So I'm using VS Code as an editor, and when I try to push some code into GitHub, that's when the GitHub Actions is executed, and that will actually invoke the Terraform scripts, which will be creating some infrastructure, both front end and back end. So for the front end, I have an S3 bucket, which actually have some static content, HTML, CSS, and JavaScript. And for the back end, I have DynamoDB and a few Lambda functions, which is actually enabled for function URL, which provides an endpoint, an API endpoint, which is called by the JavaScript so that you can communicate with the DynamoDB database. And as part of the backend infrastructure, we are also creating ACM, AWS Certificate Manager, and then CloudFront distribution. And the domain validation is also done as part of the IAC with Cloudflare. I am using Cloudflare for DNS registration as well as management. And the DNS records are also updated as part of the infrastructure. So once all the infrastructure is created, the JavaScript is updated with the function URLs dynamically. So I made sure I am not hard coding any of the content within my code, and the content such as Lambda function URLs or the bucket name are dynamically passed. So once they are updated, they will be re-uploaded to the S3 bucket. And then I'm also using Cypress for a test automation. Cypress is basically a test automation framework. It's written in JavaScript, and there are certain smoke tests that I have created. And the Cypress also has invokes these Lambda URLs, the API endpoint, and the content such as the URLs is also updated automatically. So that's about what happens from a developer standpoint. From a user standpoint, let's take a look. So user enters the domain, and there is a domain lookup that happens, and it resolves to the Cloudflare. And then I have it proxied to the CloudFront distribution. And in Cloudflare, I have actually enabled HTTP to HTTPS redirection. So any requests that are HTTP will automatically redirect it to HTTPS. And then in the CloudFront distribution, I have the origin set to S3, which actually retrieves the static assets, HTML, CSS, and the JavaScript, and it's delivered to the user. And in the browser, the JavaScript executes, and they are a series of API calls the JavaScript makes first to initialize the counter in the DynamoDB, and then it increments the counter. So the DynamoDB table is updated, and the API provides a response back to the browser, and that's when you see the number of visitors updated. So that's about the architectural diagrams from both a developer standpoint as well as the user standpoint. Now let's move on to the next step. So next step is to walk through the cloud and Cloudflare infrastructure. So let's get that started. Okay, so this is the AWS console, and let me show you some of the infrastructure that I have. So as I mentioned, I have an S3 bucket check portfolio, and I am actually creating a bucket. So this has been created manually, Terraform state. It's not part of IAC, and you have to have a place where you can actually store the state file, the Terraform state file, so that it checks whether what the state of your infrastructure is. It stores here, and next time when you run the same Terraform app apply, it will make sure it is only creating the changed infrastructure and not the complete infrastructure. So you don't have to store it in S3 bucket. You can store it in anywhere. I think Terraform actually provides Terraform Cloud, where you can actually store the state file, which is more secure, and you can use it. So this is the tech portfolio, and I have the static assets here. CSS have some images, index.html, and then JavaScript. And then I am using DynamoDB. DynamoDB is I have a table, web visits, and then I have a partition key, visit account, and then I have a counter. So I just have one item, and I have created these two attributes, so visit account as well as 60, which is the current count. And then let's move on to the CloudFront. So this is the distribution that I have, and I have set the origin as the S3 bucket. Certificate manager. So this is the ACM, AWS Certificate Manager, which provides the certificate for my domain. It creates a certificate for the custom domains, shrutianm.com, and any of its subdomains for SSL and TLS communication. And finally, I have a few Lambda functions, serverless, that I have created. There are three of them, one which increments the visits, one which initializes the visits, and one which resets the visits. So that's about the infrastructure within AWS. And then now let's move on to Cloudflare, which I'm using for domain registration as well as DNS management. So I have this domain, and let me click on manage. So here I have few CNAME records. The first one is a validation record, and the second one is for the subdomain and for the root domain, which are proxied, and it is actually reaching the CloudFront distribution. So that's about the infrastructure both in AWS as well as CloudFront. Step 5 is destroying the code. Destroying the infrastructure. So we have seen www dot the custom domain that I created, which is working. So now let's destroy this infrastructure and try to recreate it using infrastructure as a code. So for that, let me access VS Code. So this is my entire project. So first, let me do Terraform init. Okay. And then I will be using Terraform destroy to destroy this entire infrastructure. So it's asking for the API token for Cloudflare. So please give me a minute and I'll get back. So I have to enter the API token. So now it is giving me a list of the infrastructure that is going to be destroyed. So this is all the infrastructure that will be destroyed. So let me confirm by saying yes. So this is going to take a bit of a time, especially for the CloudFront distribution, as it is destroying. So first it disables the infrastructure for the distribution, and then it deletes the infrastructure. So I will pause the video and resume once the infrastructure is destroyed. Infrastructure has been destroyed. Now let's go back to the AWS console and take a look at it. Okay, this was our previous load, and let me refresh. There is no infrastructure. Let's take a look at S3. Yeah, the tech portfolio is gone, as I mentioned. So this is an infrastructure that has been created manually, and it has to be there to store the state because I'm using an S3 bucket to store the state. And then CloudFront, there is no distributions. It's empty, and ACM, certificate manager, should be empty as well. And let's look at the CloudFront. So this is our domain. Yeah, so all the CNAME records that we saw earlier are gone. And now let's try to reload the website. It cannot be reached. So every single infrastructure has been destroyed, and the website is no longer accessible. So that's step number 5, which we did. We visited the portfolio website, and it's not working. Now let's go ahead and run the GitHub workflow, which again recreates all this infrastructure, and we will get back our website. So let's see that. So let's go back to VS Code. In VS Code, I have a terraform.yaml file, which actually creates runs a series of steps such as installing dependencies, setting up Terraform, initializing it, and then applying the infrastructure. So when I actually say Terraform apply, so that's when all the .tf files that you have here, all those gets applied step by step. And then I have certain dependencies set between them so that it actually looks at the dependencies, resolves them, and creates the infrastructure in that step in one after the other. And then I am extracting the Terraform output and removing any special characters, trying to update the URLs dynamically in the JavaScript. So for example, if you look at the JavaScript, I don't have anything hard coded. So this is where the JavaScript actually calls the Lambda function URL, the endpoint, the API endpoint, and I have a variable being sent, and this content initialize underscore function underscore URL is updated dynamically, and same with Lambda function URL. So that's what the update scripts with dynamic parameters. So this step does, and finally, I am re-uploading it to S3 bucket, running some Cypress scripts. And yeah, so that's the end of it. So this is the Terraform .yaml, which is the GitHub workflow that we are going to execute. In order for this workflow to be executed, I have to push some code to main. So in order to get that implemented, let's just try to add some comment in one of the Lambda codes. Okay. So I am going to say this code will zip the Lambda function. So that's it. There is a change. And when we look at the source control, it says Lambda increment has been changed. So I am going to say updated comment in Lambda underscore increment as a commit message, and I am going to directly commit and sync. So this is going to trigger the workflow to run. So let me commit and sync, save all and commit the changes. Okay, so now let's go to GitHub. So this is our GitHub repository, Cloud Resume Challenge, and let's look at the actions. So we can already see there is this workflow running. So going back, and this is the action that has been triggered. Okay, so we can see it actually started setting up the job, checking out the repository, dependencies, set up Terraform, did a Terraform init, and then it's currently applying all the infrastructure. So currently we don't have any of the infrastructure. It's creating everything. Yeah, so it's creating each of the infrastructure. So Terraform actually gives an initial plan saying there are 25 resources to add, and then it begins by creating the infrastructure. Again, CloudFront distribution is going to take time. It has to deploy the distribution. So I am going to pause this video and resume once it's done. So actually, the CloudFront distribution infrastructure has been created, and the cache has been invalidated, but everything. And then the output of the Terraform is in JSON. Extract the Terraform output. So these are all the outputs of the Terraform. And then it's truncating and removing the special characters, updating scripts.js with the updated Lambda function URL parameters, which is actually coming from the Terraform output, which has been in turn converted into JSON. So here these are all the environment variables, and the updated scripts .js is uploaded back to the S3 bucket. And finally, we have Cypress scripts. Even in the Cypress scripts, the parameters are not hard-coded. They are being sent dynamically. And here are the scripts. There are three scripts that I have written. There is dom.cy, increment.cy, and then initialize.cy. So these scripts have also been executed and everything has been passed. And finally, the credentials have been cleaned up, and then the repository has been cleaned up as well, and the job has been completed. So that's the series of steps that have taken place on this workflow. Everything has been successful. Now let's go back to AWS and see if our infrastructure has been created. The web underscore visits, which is the DynamoDB table, has been created. And then I have the Lambda functions created. Let's take a look at the CloudFront distribution. So there is a new ID, and the distribution has been created, and the S3 bucket has been added as an origin. Yeah, and then we have certificate manager. So list the certificates. Yes, we have the certificate, and that has been associated with the distribution. So finally, S3, the tech portfolio bucket is back, which includes all the assets, and it has been updated. The JavaScript, if we look at the JavaScript code now, you will notice the URLs are updated here. In our code, we have a variable lambda underscore function underscore URL and initialize underscore function underscore URL. So those URLs have been updated, and also the DynamoDB table name is also updated. Yeah, so that's about it. Let's go back to the infrastructure once again. The DynamoDB tables. Explore table items, and we can see the counter has been initialized to 0, because obviously we have created the infrastructure brand new and there are no visitors. So now let's visit and see if it works. Yeah. So the number of visitors is now 1, because this is the first time we are visiting this website. And let me refresh, and it's updated to 2. So our infrastructure, our entire 25 resources infrastructure is back up and running. So I think that's the beauty of infrastructure as a code. So now if you had to create everything step by step manually in the console, which actually no one does, in the organizations, they usually use infrastructure as a code, maybe templates or Terraform or any other tools to help create the infrastructure. So that's the portfolio, destroying the infrastructure and creating it back. So we have completed all these steps. Now I wanted to just take some time to go through the code that I have in VS Code to help you understand the structure of how the code has been written. Let's start with the front end. Basically, I have front end, back end, Terraform, and Cypress. So let's start with front end. Front end, I have index.html, and then I have CSS as well as JavaScript. JavaScript, as I mentioned earlier, I am passing the URL as well as the DynamoDB table name. And same here, I'm passing the URL as well as the table name. So this is where I am, the JavaScript is actually making a HTTP request to the Lambda endpoint, which in turn updates the DynamoDB database. So here, the first URL initializes the DynamoDB table, and the second URL increments the DynamoDB table whenever a new visitor comes in. So that's about the front end code. Let's look at the backend code. So backend, I have initialize Lambda, which is basically going to initialize the DynamoDB attributes. I have item, visitor count, and counter, and it is only going to initialize if the count is non-zero. And then I have Lambda function, which again is going to interact with the DynamoDB database and set the counter, increment the counter. And then we have reset counter. It basically resets the counter it decrements the counter. So the reason I have this is I'm running Cypress scripts, which actually tests the functionality of the increment. So it increments, calls the API, which increments, and it is testing the increment functionality. So I want to reset the count back and not have Cypress increment the number of visitors. I want an actual visitor to increment the counter. So that's about the backend. And in the Cypress, I have three Cypress scripts. So this one is actually calling the S3 bucket static website URL, which is website URL. And it sends a HTTP request to the endpoint and then verifies if the value that gets displayed. So when I say value, which is this, the number of visitors, exactly this value in the document object model. And it makes sure it is not error loading the count value. So that's the check this one does. So the next we have is increment CY. So this is going to send a HTTP request to the API, which will increment the counter, and it's storing the initial value in initial counter. And then it is sending another HTTP request to the API and storing the counter in updated counter. So initial counter plus one and updated counter should match. And if it doesn't, it's going to fail this test case. Okay, and then initialize.cy is going to make sure HTTP request call to the endpoint is successful. It's returning a 200 status code, which is success and not erroring out. So the reason I have reset in these scripts is because we are making a HTTP request, which is actually incrementing the counter. So I am running the reset URL so that the increment is reset. So this is going to decrement the counter and set the state to whatever it was initially. So that's about the Cypress. And then I have the Terraform scripts. So all these Terraform scripts run in an order, and the order is defined by the depends. So let me, yeah, but it depends on that we have here. So wherever I have depends on, it's going to make sure the previous resource, which is on the depends on, is created before this resource gets created. So for example, when I am creating a certificate manager ACM for my custom domain, I have to create the CloudFront distribution after the ACM is created because I have to associate ACM to the CloudFront distribution. So you will see that it is dependent on the certificate resource being created. So if I don't have this depends on, the infrastructure is going to error out because the dependent resource is not created and it will not have a certificate to associate with. So that's the Terraform code. So this is going to create the ACM certificate, and this is going to communicate with the Cloudflare API and set the domains. CloudFront creates a distribution. DynamoDB creates a DynamoDB table with the partition key and attributes and the items. And then I have Lambda increment, which is going to create the Lambda function for the increment. And then Lambda initialized DynamoDB is going to create the Lambda function for the initialize dynamodb.py, and then finally I have lambda reset, which is going to create the lambda function for the reset counter. And main, this is going to set the versions as well as here is where I am saying the state is going to be in this S3 bucket. I have then outputs.tf, which is going to output a series of variables such as lambda function URL, reset function URL, table name, bucket name, etc. So this is going to actually help me pass the parameters dynamically because we are converting this file, the output of this file into JSON. and then extracting the values from the JSON and passing it on to the next steps in the GitHub workflow. This one is going to create the S3 bucket, and I have TF-vars. This is where I am setting the names of the name of the infrastructure. So I have region name, bucket name, Lambda name. So if anyone is interested to fork and create a new version of the website, you have to change these parameters. So all you have to do is just go ahead and change these parameters, and the infrastructure will be created based on the new set of parameters. And then variables. So these are the variables that are expected as part of the Terraform apply, and the default is picked from the inputs that you provide here. So that's the Terraform part of it. And finally, let's take a look at the GitHub workflow. So GitHub workflow, we have already taken a look. I just wanted to show how the parameters are dynamically passed into the JavaScript as well as the Cypress scripts. So as I mentioned, the Terraform output is extracted into a JSON. So this is where it is extracted, and any kind of special characters are removed. It is cleaned up, and then the extracted Terraform output is displayed. So this is going to display in the console when the GitHub workflow is being run. And then we have update the JavaScript with the dynamic parameters. So this code is actually going to replace wherever you have lambda underscore function underscore URL in scripts.js file, it is going to replace with the environment variable, which actually contains the actual URL. And similarly, initialize function URL is going to be replaced with the environment variable for the initialize function URL, and the same with DynamoDB. So this is how the scripts.js file is updated with the actual lambda URLs as well as the DynamoDB table name. And finally, the updated scripts.js file is re-uploaded into the S3 bucket. So if we take a look at the S3 bucket, the tech portfolio, index.html has been created on August 13th, 653, right? JavaScript. Scripts.js is created on 658. So it has been again re-uploaded with the updated parameters. And similarly, CSS should be created on 653, yes. And images 653. So that is what it is. JavaScript scripts.js has been re-uploaded with the actual function URLs as well as the DynamoDB table name. So that is the actual infrastructure. And I have these files are the Cypress configuration. And all this code is in the GitHub repo, Cloud Resume Challenge, and I will be sharing the link for this repo in the description. So that's about step number 10, where we have where we did a walkthrough of the structure of the code in VS Code. So just wanted to kind of give you some insights about some of the mods. So this challenge also has a few mods that you can implement. So mods are basically, it has a developer mod, it has a security mod, and it has a DevOps mod. Apart from the challenge, if you are interested, you can actually choose specific mods and kind of enhance the existing challenge and take it up a notch. So I wasn't able to do all the mods, but I was able to implement a few mods. So first is the DNSSEC. So this is where you would actually enable DNSSEC in the Cloudflare. So in Cloudflare, you have an option to enable a DNSSEC. Again, I'm not sure if all DNS providers actually has this option enabled, but Cloudflare does. DNSSEC actually uses cryptographic signature, as it says here, and it will protect your domain against forged DNS answers. So based on the type of the record, whether it's CNAME, TX, MX, or A, there is an RR set associated to each group, and each RR set has an RR sig, which is used by the domain resolver to make sure it is coming from the actual name servers. And how do we make sure the RR sig is valid? It is actually valid because there is a chain of trust that is built where there is zone signing keys and key signing keys, which actually make sure that RR-sig is coming from the actual source and it has not been tampered. So that's a bit of a history about DNSSEC. It's all about enabling it in the Cloudflare. And then I have also built some dashboards in Datadog as well as PagerDuty. So within PagerDuty, I have created some triggers here. So for example, if the number of invocations to the Lambda is more than a certain threshold, I am actually setting triggers within the PagerDuty, which automatically creates incidents, and it also notifies in it also notifies via call or messages, and also in the Slack channel. So I created an integration between PagerDuty and Slack as well. So basically, when you are setting alarm in CloudWatch, you select the notification being sent to PagerDuty, and that is done by the integrations. And that is going to trigger incidents whenever the state is in alarm state, and which will create these incidents. And if it has any kind of integration, it is going to send you Slack notifications, make a call, send a message so that you are notified. So that's about the PagerDuty. And I have also tried the Datadog. This is Datadog, which actually gives you metrics, insights of the infrastructure that you have in various platforms. So it's great for observability and telemetry data, and it helps you keep a track of what's going on in the infrastructure. So you have integrations here, and let's pick AWS. So this actually provides a CloudFormation stack, which in turn creates a series of resources within your AWS account. So the creation is in progress, and this is actually going to take some time. So I'm going to pause this video and resume once the creation is done. Okay, now let's type AWS and see that it's installed, it's configured, and the integration is working. So going back to Datadog, let's click the dashboards and let's pick some dashboards which are already available. I am going to pick Lambda. So currently there is no data because we just installed Datadog, and it's going to take some time to pop up. So if we take a look at the Datadog, we can see the Lambda functions are appearing here along with the Datadog integration Lambda function as well. So this is basically used to pull the metrics and show us in this dashboard. So if we ignore the Datadog related infrastructure, so we have increment visits, we have initial visits, and we have max execution time, and function with most errors, it's all 0, and we totally have 11 invocations so far. So Datadog actually gives these kind of metrics at the infrastructure level. It is much more robust, and you can create different kinds of metrics based on your requirement. These are all different kinds of metrics that you can create based on your requirement. So that's about the metrics aspect of it. And I have also tried configuring the GPG key. Basically, the public key is stored in GitHub, and using the private key, any commits that are made from the VS Code is digitally signed by the private key, which can be validated by GitHub using the public key that the commits are coming from me. So it's a kind of cryptographic signature that is used to validate the authenticity of the commits. And I have tried that with one of the commits. So if I look at the commits, I should be seeing verified. So this actually tells me that the commit has been verified. This commit was created on GitHub and signed with GitHub's verified signature. So I have actually used the GPG key to get this working, configured and integrated with GitHub, and GitHub uses the public key for this key ID to actually validate the authenticity of any commits. So finally, step number 12 is the challenges. Some of the challenges that I actually faced in some of the unfinished mods, I just wanted to kind of give you an overview. So first and foremost, adding the custom domain to Azure CDN. So before I started this whole project in AWS, I started it with Azure and it was working, everything was perfect. However, I wasn't able to add the Apex domain to the Azure CDN. So I was able to add the subdomain www.shrutianm.com. However, the Apex domain I wasn't able to add. I was getting an error saying I cannot add the Apex domain. And upon research and struggling with it for a week, I decided to switch to AWS. And similarly, I actually used Cosmos DB instead of DynamoDB and Azure Functions instead of Lambda. Even with Azure Functions, I had trouble where once I deployed the function, the function, the trigger, the function that I created and the HTTP trigger that I associated, that was disappearing from the console for some reason. I don't know if I was not creating it right, but it wasn't working. Again, I tried it for a couple of days, and that was another reason for me to switch to AWS. X forwarded for. So another challenge in the mod was to actually increment the visitor count only if it is coming from a unique IP. And I tried this for a couple of days and I wasn't able to figure it out. I used the X forwarded for header, which is actually used to store the client IP, and within the Lambda function that you have, which increments the counter, actually validates the IP address, which is in the X forwarded for header, and only increments the counter if it is coming from a unique IP. I tried implementing this, and for some reason, I wasn't able to figure it out, and it was actually breaking some of my other code. So I decided to move on, and maybe something that I will pursue later. And finally, OpenID Connect. OpenID Connect is actually a secure way of accessing the credential information, AWS credential information, instead of storing it in the GitHub. So for example, if we take a look at the roles and try to create a new role, so instead of creating it for a service here, you have to select web identity and choose the identity provider as the GitHub, which whenever GitHub workflow is being run, it actually assumes this role and requests temporary credentials and communicates with the AWS account. So this is a more secure way of communicating with the AWS instead of entering the credentials as GitHub secrets, because it is using the temporary credentials which gets expired after the GitHub workflow is finished. So that's about it. This one as well, I wasn't able to kind of figure it out for some reason, maybe something that I will pursue later. So that's about it. These are the steps I wanted to kind of walk through and help you understand how I created this infrastructure. I am going to share the details of the GitHub repo as well as the Medium blog that I have written explaining the experiences and the steps that I have taken. Thank you so much. I hope this session was helpful. And if you have any questions, please reach out to me. Thank you.